Hi, today we'll be discussing about Dropbox or Google Drive system design. So what are these? These are cloud services which helps storing the file or backing up the file or syncing the files and so on. So this is file storage cloud services. What if we are asked to design a system like this? So let's first look at the requirements. Uh, so we have two types of requirements as usual, functional and non-functional. So starting with functional requirements, there are three functional requirements that we need to consider. The first one is a user should be able to upload a file. The second one is user should be able to download the file, and the third one is the files should sync across devices. These are the functional requirements as a part of our scope of the video. Coming towards the non-functional requirement, we have three non-functional requirements. That is high availability. The system should have a high availability, low latency upload or download in the system, and the system should support large files as well. Let's talk about the APIs which would be required for designing such system. The three APIs that would be required to resonate to those three functional requirements. The first one is upload a file. So for upload a file, of course we are uploading a file to the server, then for that we need a post method request which would be having a route called, let's say, slash files, and its body would contain file and its details. The second one would be for downloading a file. So for downloading a file, we'll be having a get method request, for which the root would be slash files for downloading multiple files, and slash file in query param id for downloading a single file. Then the third API for a file sync across devices would be slash changes, and the method would be get. So those changes would be passed as a request, the changes between local and server DB. And what is a local DB and so on, we'll be discussing further in the video in the high level design of this system. So this was all about the APIs that are required to fulfill our functional requirements. Going further towards the high level design of this system, this is the whole high level design of the system which you can see on the screen. Starting with the client. So in this case, the client would be consisting of multiple elements. Let's first discuss about those elements, starting with chunker. So we have chunker, local DB, watcher, local folder, indexer, and so on in the client. Starting with chunker. So what is the purpose of chunker? We'll be seeing each of the purpose, function, and why is it used for all these elements of this client. Starting with this chunker, what is the purpose of this chunker? To efficiently handle files. So what basically a chunker does is, let's say we had a non-functional requirement, the last non-functional requirement, that the system should be able to handle large files. Assume you are uploading a movie of, let's say, 2 GB to a file, right? It will obviously take time. If you're uploading it in Dropbox or Google Drive, anywhere, it will obviously take some time. If you are uploading it as a whole, so if you are uploading it as a whole file, it would take time. And the other issue is, let's say if you are facing some error, let's say 90% of file has been uploaded, but in the last remaining 10% there's some error identified. So that particular error would cause the whole file to be retried again, and it would consume your that much time again. This is a waste of time for the user. So how can we avoid this? So chunker is one solution. So what chunker does is, it splits the file into multiple smaller chunks. So a whole large file is divided into multiple smaller chunks, and those chunks are parallelly uploaded, which saves the time. And even if any error is occurred in any of the chunk, only that particular chunk is retried and not the entire file. So this is the function which I said. It splits large files into smaller chunks before uploading. Why is it used? It is for efficient uploads. Uploads can be paused or resumed, and only the changed chunks need to be re-uploaded are changed. Parallel uploads. Chunker allows multiple chunks to be uploaded in parallel by speeding up the process. and it handles error as well. If a chunk upload fails, only that chunk is retried and not the entire file, as I said. So this was about Chunkar. Coming further to LocalDB. The purpose of LocalDB is to store metadata. Now, metadata is nothing but file information, like file paths, where is the file stored, or the version of the file, or the sync status, is it synced or not, or is it in process, or whatever, and the timestamps. And there could be multiple other informations as well. So this is the function of LocalDB, to store this metadata locally, not on the server, locally. And why is it used? So the first use is its quick access. So LocalDB reduces the need to query the server frequently, improving performance. The second one is offline access. It allows users to access and modify files offline, sync changes when reconnected. So let's say if a user is not connected to the internet currently, then if he or she is uploading or updating that particular file in this kind of system, like this Google Drive or Dropbox, then LocalDB would be updating the information, and whenever the user is again connected to the internet, the changes would be then synced to the server. The third one is conflict detection. So it tracks file versions to detect conflicts when multiple devices make changes. So this was about LocalDB. Moving further towards Watcher. Watcher, from its name we can understand what could be its purpose. So its purpose is change detection. So Watcher continuously watch to the client what changes are being made. So it monitors the local file system for any changes such as addition, deletion, or modifications. Why is it used? The first use is it's real time, for real time syncing. So Watcher ensures that changes are detected and queued for sync almost immediately. So whenever a user adds a file or deletes a file, or make any changes in the file, Watcher would be the one who would be identifying that particular change. The second use is efficiency. So Watcher reduces unnecessary scans by only reacting to specific file system events. And the third one is conflict prevention. Watcher identifies potential conflicts early by detecting simultaneous modifications. Going further towards a local folder. So the purpose of local folder is it's a kind of user's interface with Dropbox. Its function is it is nothing but a directory on the user's device where files are stored and managed locally. And why is it used? It provides seamless experience. Why? Because it acts like any regular folder, making the cloud service feel native to the user. And it lies on user device, right? And it's another use is an automatic synchronization. So files placed in this folder are automatically synced with the cloud and other devices. Going further towards indexer. So what is the purpose of indexer? So its purpose is file organization and metadata update. So how it functions? So it scans and indexes files in the local folder, updating the local database with relevant metadata. So whatever changes are identified by Watcher are being updated in the local DB and the local folder by this indexer. Now, why is it used? For efficient syncing? Obviously it helps, as it helps determine which files need to be synced based on changes in metadata, like size or last modified time. So let's say if the last modified time is different in local and in the server, then when the sync service, will be talking about it further in the video as well. So the sync service would identify the changes between local and server based on, let's say, the last modification time, which would identify there's a change and what is the change. So those change would be then synced by in the database. So for efficient syncing, indexer is being used. The second use is conflict resolution. So whatever conflict are detected by Watcher are further resolved by indexer, as it helps in maintaining consistency by comparing local and cloud versions. So that was all about the elements of this client. Going back to our high level design, so after, like, whenever all these functions are performed in the client, the request then further goes to load balancer and API gateway. Load balancer for managing the load through from different clients and passing it and for deciding which instance of the service, like a single service, let's say this file service can have multiple file service on multiple servers. So what server would be receiving this particular request would be decided by load balancer, and which service this particular request should be passed either to file service or to sync service would be decided by API gateway. So let's say whenever, let's go one by one with the requirements, the function requirements. So first, let's say a user uploads a file. So what happens when a user uploads a file? The file is divided into multiple chunks. Those chunks are, and there's a watcher who is watching that something has been done. Like these files, these chunks are when uploaded to local folder. A watcher identifies that there is some action done in local folder. So a change is detected in this local folder, and those change, the information of those chunks are then modified by this indexer, in the local DB. So local DB would be having those changes, and a request would be then generated to the server for storing these details in the server. Now how it gets stored? So this upload file request, as I said in the API section, that upload file would contain file and its information related to the files. So the body of that particular request would contain those informations, and those information would be then passed as a part of request to the file service. File service will store those chunks in a blob storage, let's say S3, and the information, the metadata, in the database, in server database. And what would be the fields of metadata? So these could be the fields. There could be many other than this as well. So this are the basic fields that should be there. That is file name, file type, size, user ID, which user has uploaded, which this file belongs to which user, when was it created at, and when was it updated, and the chunks as well. So this file contains how many chunks, and where is each chunk stored, that is this S3 link. So in S3, where is this each chunk stored, and what is the ID of that particular chunk? So we can so this is the file metadata. Now this was all about uploading a file. So the file is uploaded. Now what if the user want to download a file? So when a user want to download a file, the request of get files would be provided. The information of that particular file would be fetched from this file metadata, and through this file service from this S3 link and or this ID or anything, those actual files, the actual chunks, would be then fetched from this blob storage, and those information along with this chunks would then process the file, and that particular file would be then provided to the user as a part of his download activity. This was the second functional requirement. The third functional requirement is file sync across devices, right? Now let's assume if there's a change made here, this client, let's say we have two clients, that is A and B, two users, I mean user A and user B. So user A is making some change from his device, and user B is making some change in his device in the same file storage for, let's say, the same particular file. So what would happen is, let's say user A is making some change in his device. The change would be then like here the watcher would identify there's some change made here, right? So this sync service job is to continuously get the changes. So it will get the changes from user A. So all those changes from user A which the sync service got would be then processed through this file service, and those information in metadata would be updated, and in the block storage would also be updated. Now the local db the local db of user B and other users should also be updated, because now there's an old file for user B in his or her local system, but the cloud system has been updated with the new file. So those information through the sync service again would be fetched from this file metadata and would be applied with the changes in this local DB. So this is how sync service will work for syncing the file into multiple devices. So yeah, that's it. That's all about this video.